Hi, everybody. My name is Andrey. I am a Chromium engineer working on developer tools and Puppeteer. So today, we will talk about modern web testing and automation with Puppeteer. Today's talk is split into a few parts. First, I will introduce you to the Puppeteer. Next, there will be an announcement. And then after that, we'll talk about testing. So we will discuss testing fundamentals, and then we'll dig into real powerful stuff. Finally, we will wrap up with our community. So let's start. So what is Puppeteer? Puppeteer is a browser automation library. It brings the power of web to Node.js with simple-to-use and easy APIs. So with Puppeteer, you can do many different things. You can open pages, you can navigate to different websites, and you can even evaluate JavaScript inside the context of the website. So you can do many more, and we'll talk about this. But seeing once is actually better than hearing, so let me introduce you to the Joel's personal merchandise website. Now, Joel is a Chromium engineer as well. He works on DevTools and Puppeteer with me. And on this website, Joel sells t-shirts, coffee mugs, stickers, all with his name on it. So my personal favorite is this t-shirt. Unfortunately, it is a little bit pricey for me. It costs $50. So every once in a while, I keep going to this website in the hope of a discount. Now, turns out this is a perfect task for browser automation. So let me show you how I did this with Puppeteer. So first thing I did is actually npm install Puppeteer. And when Puppeteer is getting installed, it downloads a browser version it can work with. So this already eliminates one of the biggest points of browser automation. With Puppeteer, there is no need to configure, link, or otherwise manage the browser installation. I can just do npm install and go right into the coding. So let's code. So this is Node.js, and this is Node.js script. So first thing I do, I require Puppeteer. So all my automation code will go in between these parentheses. So I use async function here so that I can use async await syntax of modern JavaScript. So first two lines, I launch a browser, and I open a new page. Now, Puppeteer operates mostly headless, but you can configure it to be headful. Now, in the top right corner, you can see the visualization of what it actually does. So here we can see a browser with a new page. Next, I navigate this page to the Joel's website. And I know that Joel stores his price in a specific CSS selector. So I can use Puppeteer API to fetch the price and output it to Node.js console. So here is $50. Yes, and the last thing, I close the browser. OK, so just 6 lines. It's as easy as that, really hassle-free. Nice. So I had it running for a few days. And here's the chart of prices of Joel's t-shirt. So unfortunately for me, the price did not go down. In fact, it even went up. So with this, I have one last hope. I have heard that certain websites show different prices depending on the browser I use. So Puppeteer is all about Chromium. But today, I'm happy to tell you that there is another browser that is joining Puppeteer family. And with this, let me introduce you to Puppeteer for Firefox. Thank you. OK. So Puppeteer Firefox is currently an experimental project. It is everything Puppeteer, but for Firefox. It is available on npm. It already supports 90% of Puppeteer API. And we are working with Mozilla, and we are happily collaborating with them on bringing the missing functionality to Firefox. So let's see what it takes to run my monitoring script with Firefox. OK, again, first thing I do npm install Puppeteer Firefox. And this too downloads a browser, but this time it is not a Chromium, but Firefox. So now I'm ready to go coding. And turns out I can do just one thing. I can just substitute my require from Puppeteer to Puppeteer Firefox. That's it, no more changes. So let's see how it worked out. So, OK, turns out something went wrong. Let me zoom it in for you. OK, so yes, my automation adventure did not succeed, but we found a problem. So turns out Joel's website doesn't work in Firefox. Joel is a great web developer, and Firefox is a great web browser. But things require testing, and sometimes cross-browser testing. So why didn't Joel test his website for different browsers? So Joel wasn't able to come here, but I checked with him. And it turned out that Joel was scared. Joel was scared that web testing is complicated, that it's slow and flaky, and that he will spend more time maintaining his tests than developing his website. So this being Puppeteer talk, we think Puppeteer solves all of these problems. So let me introduce you to the new web testing powered by Puppeteer. Let's see how we can address these challenges. So first up, Joel thought that testing is complicated. Well, with Puppeteer, this is not the case. We saw together that it's just one npm install, and it already works. There is no need to set up anything. So no configuration, a simple npm library, similar to TypeScript or ESLint that you are already probably using. So then, what test runner do we use? Well, with Puppeteer, you're free to choose your favorite one. Puppeteer supports all of them, be it Jest, Ava, Mocha, Jasmine. There are many of them around, and it works with all of those. So one thing is to run tests locally, and that's a completely different story to deploy your tests to a continuous integration. Well, Puppeteer runs everywhere. It runs on all desktop platforms, but it also runs on all your continuous integration services, be it Travis CI or Upware. And in fact, we personally run all Puppeteer tests on both Travis and Upware to make sure that the integration is smooth. So if you happen to be in a cloud, Puppeteer works on Google Cloud, on Azure, on AWS, everywhere. And if you need to, Puppeteer also works in Docker containers. OK, next up, Joel thought the tests are slow. But how come? Like, if you think about that, web as a platform is actually pretty fast. And we all work hard to make sure that our websites are responsive and fast. So why are our tests slow? So one of the reasons might be that we keep reopening a new browser instance for every test. And we might have a good reason to do so. With this, we can isolate tests between each other. So things like local storage, cookies, IndexedDB, these don't interfere between different tests. Now, this has also a downside. Relaunching a browser, even a headless browser, takes time and also resources. So with Puppeteer, you don't have to relaunch a new browser to isolate your tests. There is a nice feature called browser context. And browser context isolate cookies, local storage, everything. So they're basically incognito for Chrome. So for tests, this means that you can have all the benefits of browser relaunching, but faster. Actually, 100 times faster. So we encourage you to use browser context when you test with Puppeteer. So let's see how you can do that. So here is a typical Puppeteer test. So it goes and checks that there is a pay button on the Joel's website, but the important parts are the very first and the very last lines. In the very first line, I open a browser, and in the very last line, I close it. So let's change this and make it way faster. So now I will pop my browser instance up outside of the test. And inside, I will create a new browser context and close it after the test is done. Now, this is a simple change, but it is already a huge performance win. Lastly, Joel thought the tests are flaky. And test is called a flaky when it passes one time and fails another one. A common workaround for that is to add a set of retries around your tests. But this is actually a workaround, it's not a fix. So let's take a look at a flaky test. So this is a simple test that verifies that I can click and a pay button, and the payment goes through. So I open a page, I navigate it to merge site, I click a button, and I wait for payment to succeed. Now, this is a flaky test, because first, the button, the pay button, might not appear after my navigation if it is inserted with JavaScript. And the payment might not go through after the click, so I have to wait for something. So if you have been doing web testing before, you might know that a common solution for this is to throw in a bunch of sleep calls. Well, let's sleep for a second everywhere. However, this leads to two different problems. First, I might sleep too much. So what if the button appears right after the navigation, but slightly later, but I'm already sleeping for at least a second? Second, how do I know that second is enough? What if I run on a slow environment, on some system that has a huge load? So 1 second might not be enough. So this leads us to a flaky test again and doesn't actually mitigate any troubles. So with Puppeteer, we have a perfect solution. Puppeteer has a set of APIs, and we call these reactive or wait-for APIs. And these APIs let you react on DOM modifications, network activity, complete navigations, many different things. So this is very powerful, and it helps us with reliable testing. So let's see how we can actually fix that test. Okay, so first, this wait for 1 second. I will substitute it with wait for selector. And now this waits for just enough for my button to appear. So next, I will do some other trick. Let me indent it for you. So I will remove this last wait for. And before I click the button, I will set up a watchdog. So this is a promise that will resolve whenever the response for the pay endpoint comes into the page. Now I will click the button and await this response after the button is clicked. So this is it. The test is not flaky anymore. But these 3 lines are a little bit clumsy. So actually, we have a better way to write this, and we call this a promise all pattern. So instead of doing this response and awaiting response, I can rewrite with this thing. I can combine an action and a watchdog together in a promise all and wait for an action to succeed. Okay, so this was quite easy, and the test is not flaky anymore. So let's recap. So Joel was scared of web testing, but he were to use Puppeteer. None of his fears would apply. So testing with Puppeteer is fast because of the browser context. Testing with Puppeteer is reliable because all of the wait for APIs we have. And testing with Puppeteer is simple because it's so easy to set up and get running. With Puppeteer and Puppeteer Firefox, Joel can test his website in both Chrome and Firefox. Okay, let's switch gears and talk about web testing fundamentals. So, what is web testing? Web testing largely consists of 3 main things. It is how do we navigate to the page, how do we evaluate things inside the page, and how do we click and drive input into the page. So no matter what you do, be it a web testing or general web automation, you rely on these. For a browser automation library, it is very important to have these right. And before we talk about how these things work in Puppeteer, let me show you puppeteer.dev. Puppeteer.dev is an interactive documentation website. On this screenshot, you can see what it looks like. Puppeteer.dev lets you fuzzy search across all of Puppeteer documentation, be it events, methods, or everything. So this is a modern web application. It works offline. It does client-side navigations and everything. So let's see how we can navigate to this website with Puppeteer. So as we saw before, we can use page.goto. And page.goto is a method that returns a promise. And the promise resolves whenever the page emits a load event. This is quite natural. So if we actually try to do this with puppeteer.dev, we will end up here. And this is not how documentation looks like. In fact, this is puppeteer.dev loading stub. So the very first time you visit this website, it fetches all the documentation for all the releases of Puppeteer from GitHub. So it takes time, and load event happens too early. But Puppeteer lets you wait for different events using the wait until option. So let's see what we can wait for. This chart shows you the network activity of puppeteer.dev loading. Time flows from left to right, and a few events are marked with vertical lines. So, and requests are these horizontal lines you see. The very first event is DOM content loaded. This happens whenever the browser fetches the main resource and parses all the HTML. You can wait for it with wait until DOM content loaded, but it is too early for our website. Next is the load event. It happens later when all the resources, direct resources of the page are loaded. This is the default one we wait for. And this is too early, as we saw it, for puppeteer.dev. Now, we can see all this network activity that happens after the load event. These are actually the fetch requests that fetch the documentation. And 500 milliseconds after the very last request completes, we have another event called network idle 0. So this event happens after 500 milliseconds of network radio silence. And this is what we should use for puppeteer.dev to navigate. And we can do this with wait until network idle 0. OK, so with Puppeteer, we have all these options to wait for when we drive a navigation. Now, let's talk about navigations that happen indirectly. Let's talk about clicking links. For example, I can click a link on a website, and it will drive me to somewhere else. So there are different types of navigations. For example, when I navigate to a different website, this is the very first and simple navigation that has been around since the early days of internet. Now, there is another type of navigation when I click a link and the page scrolls to a different location. And this is called anchor navigation. Finally, in the modern world, there are single-page navigations. So there is a chunk of JavaScript that handles your clicks, and they use history API to push different URLs. So here's a short video of me clicking links on puppeteer.dev. So when I click on a browser or a page, this actually drives a single-page navigation. But when I click on an event emitter, I'm getting redirected to a Node.js documentation website. So all these clicks have one thing in common. They actually change the URL. And the URL change is what Puppeteer considers to be a navigation. And there is a special method in Puppeteer that lets us wait for upcoming navigation. This is page.waitForNavigation. So let's write a simple script that navigates to puppeteer.dev and clicks a few things. So first thing I do, I launch a browser and open a new page. Now, if we were to use a simple page goto, I would end up here at the loading script. So no links here to click. So let's not do this. Let's instead wait for network idle. And this brings me to the desired documentation website. Now I will use my promise all trick, and I will click the very first link in the sidebar, which happens to be a documentation outline, and I will wait for the upcoming navigation. And this transitions me to the desired state. Puppeteer has a variety of APIs to help you navigate around. Besides go to and wait for, there is a go back and go forward that traverse browser history stack. So navigations, done. Next up, evaluations. So Puppeteer, like other browser automation solutions, lets you evaluate code inside the web page. Well, this is very powerful and nice because it lets us use web APIs to drive our automation. Now, however, unlike some other browser automation solutions, Puppeteer script lives outside of the browser process. Communication between Puppeteer and browser is powered by DevTools protocol, and thus everything you do is async. So why is this important? Let's see. So here's a simple script. It navigates to a page and counts the number of all links on the page. So notice that everything here is actually happening in the Node.js land, in the Node.js process. However, with the one exception of this function that is passed as the first argument of the evaluate. So this function is actually serialized and transferred over to the browser to be re-evaluated over there. If instead of doing all this link counting, I will try to use a browser or a page inside this function, I will fail. These are undefined in the browser context. And this has some very important implications. So Node.js state does not leak into the browser and website being tested. So website doesn't actually know it's under test. And as a result, we can't ship test-specific code, accidentally or intentionally. So the big takeaway of it all, testing with Web Puppeteer is very, very foolproof. Last fundamental we want to cover here is input injection. So one of the most important features of web automation is how we actually drive input into the web page. And one of the popular ways to do so is to use web platform APIs, such as dispatch event or click. So these go straight into the V8, the JavaScript engine, and these do trigger event listeners, but they do very different things when compared to real user input. So real clicks traverse the whole browser and reach to different subsystems. They cause text selection, they cause CSS pseudo-selectors, they pierce into iframes and shadow DOM. So neither of these happen with dispatch event. However, Puppeteer simulates keyboard and mouse events really precisely. The events we simulate traverse the Chrome the same way real user input would. So with this input simulation, you can be really confident that if your site works with Puppeteer, then it works for your users. Now, there are different APIs in Puppeteer to drive input. There is a so-called Puppeteer keyboard and Puppeteer mouse, and there are even sugar methods to help you with typing and clicking. Let's write a short script to demonstrate input injection. So, since all we talk here actually applies to both Puppeteer and Puppeteer Firefox, let's use Puppeteer Firefox instead for this example. First 2 lines. I launch a browser and open a new page. And since we are using a Firefox browser, you see in the top right corner, there is now a Firefox frame. Now, we can navigate to puppeteer.dev and notice that I did not use the network idle because I can do better. I can wait for the search input field to appear. And once it's there, I can type right into it. After that, I will use my promise all trick to hit enter and wait for the navigation. So let me show you a slow-mo of what it actually looks like. So this is Firefox automated with Puppeteer, so it does type. So you see typing is slow. This is because we have a 200 milliseconds delay between the keystrokes. Otherwise, it's impossible to see. Sorry. Summary. So, navigations. No matter what kind of navigation your website does, be it a single-page navigation, anchor navigation, or all-style navigation, Puppeteer Navigations handles all of them. So, evaluations. So, tests are well isolated from your web contents. So, tests are very foolproof. And input, well, Puppeteer generates real input like no one else. So, this is it for fundamentals. So, let's move to the powerful stuff and testing for the modern web. So modern web is not what it used to be 10 years ago. So every other website today is a web application. We care a lot about things like performance, accessibility, and today's web platform is actually great because it lets us do all this crazy stuff. But how do we test for them? Let's have some examples. First, mobile. It is 2019, and our websites are mobile first. So a lot of effort is going into making sure that every other website can open reliably on an iPhone, or a tablet, or a desktop. And we can do it in different ways. We can do a fluid layout, or sometimes we can even build a separate version of a website. So no matter what I do, how do I test this? Well, manually, I can open my website on an iPhone or on an Android tablet. So these are nice, but how do I actually make sure that all my hard work does not regress over time? So I need automatic testing. So you can do this with Puppeteer, and let me give you an example of how we can test Joel's website and make sure it works on mobile. So I will write a simple test that verifies that there is a pay button on Joel's iPhone version of the website. So first thing I do, I create a new page, and it's important here, as you see, that the page is actually shown as a browser page. Now, with one line of Puppeteer API, I transition this page from being a desktop page to an iPhone page. So now, when I navigate to Joel's website is absolutely sure that it is being opened on an iPhone. Now, it is easy for me to make sure that the wait button is there, and I use the wait for function so that my tests are not flaky. Okay, so device simulation, this is what we call it in Puppeteer, is actually very precise. We not only emulate the viewport size, but also DPI, touch support, user agent, landscape orientation, all of these things. And all of these things are available for more than 100 different devices that we ship together with Puppeteer and keep updated. So no matter what you use, be it a tablet, Androids, iPhones, you can test it with Puppeteer. And with Puppeteer, you can make sure that your important checkout workflow now works on mobile. So this is really important for many different applications. So next up, offline. So offline support is a big deal for certain types of web applications. For example, for a map, for subway map. But turns out that even the regular websites can take a lot of advantage of supporting the offline mode. This is Joel's website, and Joel's website shows you a big red banner, you're offline, whenever it goes offline. So this is not optimal, but it's very informational for the user. So how do I actually test this? Well, manually, I can use Google Lighthouse, for example, to make sure my website works offline. Or I can open DevTools and enable offline mode. Or I can even go and turn off my router, or load the website on a phone, and enable airplane mode. But automatically, I can test this only with Puppeteer. So let's do a simple test that makes sure that Joel's website shows this red banner whenever I go offline. So I open a page and I navigate to the merge site. And now, this is an important line. I transition this page from online to the offline state. Now, if the page issues any events, these all will be aborted with a no internet connection error. All the APIs, web APIs to notify the offline mode will be also triggered, so Joel's website can react appropriately. So now I can just wait for this red box to appear and ensure it's there. So this test is not only easy, but actually a pleasure to write, at least for me. So now, if our website supports offline mode, chances are high that we actually have to deal with service workers. And service workers are a new set of APIs on the web. So these are really complicated beasts. So these help us with caching, and they can do many different sets of things, but they're hard to use and hard to configure. So when we were doing service workers on our puppeteer.dev, we actually used a special library called Workbox. Now, Workbox takes some time to configure as well. So how did we test and make sure that we did it properly? Well, only one way today, and this is go to DevTools, navigate to Application Panel, and find the service worker in there. Turns out, it is way easier and simpler to do this automatically. Let me show you how. So let's write a test that verifies that service worker is actually getting registered for the puppeteer.dev. So I open a page and navigate it to the website. And now, a very important thing is actually happening under the curtain. Not only the page is getting navigated to this URL, but the service worker is getting registered in the browsing context of the page. Now I can actually wait for the target to appear, and I can verify that it's a service worker. And this is already a good test. It makes sure that service worker is there, that it gets registered after the navigation. Good stuff. But actually, there is more. So let me bring you to a separate slide to have some room. Once I got service worker target from the browser context, I can attach to it. And now with this worker instance, I can evaluate code inside the context of the service worker. Now, I can do many different cool things. For example, like here, I can make sure that service worker cache has my Puppeteer logo there. And many others. Actually, this opens limitless possibilities for unit testing of service workers. So we are very happy with that, and we think this will make service workers on the web way more reliable. So service workers are cool. You know what else is cool? Geolocation. Okay, so the world is global and the web is global. So your app is probably global as well. So for example, there is a map on your website and you want to show a user their location. Or another example, you have a news feed and you want to serve different content depending on the location. So how do I test this? For example, how do I test that my website works in London? Well, let's see what it takes today. Well, first thing I do, I navigate to my website and I grant permissions for it to fetch my geolocation. After that, I can open DevTools and I can simulate London over there. Well, this is the only way, and this is manual. Well, it turns out you can do the same thing with Puppeteer automatically. Let's do that. So Joel's website shows prices in pounds if you were to open it in London. So this test will validate this. The very first thing I do now is actually overriding the permissions for the browsing context and for the Joel's website to make sure it can query for the geolocation. Now, when I create a page in this browsing context, I can convince this page that it is actually located in London. Now, when I load Joel's website in there, Joel's website fetches the geolocation. It gets permission to do so. It thinks it's in London. And it serves me a price in pounds. So good job, Joel. So this was it for geolocation. Please test it if you have it on your website. And we will move on to the very powerful stuff, network monitoring. So network monitoring was always very hard in browser automation libraries. So today's golden standard for network monitoring is DevTools Network Panel. DevTools Network Panel gives you a waterfall of all the requests and responses that come in and out of the page. You can see many different things. You can see response status codes. You can check for headers. You can check contents. Now, is Puppeteer can do all of these, but programmatically. Puppeteer provides two events, request and response, that you can subscribe to. With these events, you can recreate DevTools Network Monitor in your console. So this is cool, but there is more. You can actually fetch for post data. You can fetch for content. And for responses, you can even make sure that they're coming from cache or from a service worker. This is very powerful stuff. But we don't stop here. Because besides simply monitoring traffic, Puppeteer can modify it. We call this feature request interception. To demonstrate this feature, let's substitute every image on the web with a random cat. So this is Google developer.com, and this is what it would look like if with the substituted images. Let's understand how it works. So say there is a page on the left and servers on the right. And there is an image on the page that naturally issues a request. Now, this request is intercepted by Puppeteer, and since we can inspect the request and see that it is actually coming from the image, we can respond with a cat image. However, if there is a style sheet that issues another request, we can see that it is coming from a style sheet. We don't have anything to do with style sheets, so we can let it go to the server and return the original content. Let me show you the code for this. It is really simple. So these are just 5 meaningful lines. So first thing I do, I enable request interception. Then I subscribe for the request event. And if request is coming from the image, I can fulfill it with a different response. Otherwise, I continue and let it go to the server. So we actually have a bit of fun surfing web with this feature. And this is a video of Twitter with codification enabled. So Twitter actually looks nicer this way. So what does it all have to do with testing? Turns out request interception is a perfect technology to do server mocking. Joel's website has a specific piece of logic that handles payment abortions. So let's write a test that validates that this red box appears. So first, I enable request interception, and I subscribe to the request event. Now, if the request is going to the payment endpoint, I will just abort it. Otherwise, I will load everything. So now when I navigate to Joel's website, it loads just fine. But when I click a button, it actually becomes red because I aborted the request. And I can wait for this selector to appear on the page. So this was it for request interception. There are many other different applications, but unfortunately, we don't have much time to discuss them. So with this, let's talk about performance testing. So how do you test for performance today? So the obvious choice is to go and use Google Lighthouse to get an overview of your performance. But let's look how you can investigate your runtime performance is Puppeteer. So first and foremost, our favorite API is page metrics. So this lets you pull a lot of interesting stuff from the page. You can see a number of nodes, frames, event listeners, but the very important one is the memory usage of your page. So with this, if someone complains that your website is slow, you can actually check how much memory it takes, and maybe you can optimize and fight some memory leaks. Next up, coverage, tracing, sorry. So tracing was developed originally for Chromium browser engineers. It lets you see all the insides and guts of browser working across all the processes on all threads. It shows you the GPU thread, it shows you the audio thread, everything. Turns out, over time, this proved to be really valuable for all the performance nerds on the web. Some Chrome tracing before was available in the DevTools. But today, you can do this and automate certain scenarios with Puppeteer. So say, for example, we have this simple scenario. We navigate to Joel's website, and we select a different item there. We select a mug. So now with Puppeteer, we can enable tracing in the very beginning and let it go to the trace.json file. After the scenario is finished, we can complete the trace. As we have the trace, we can go and analyze it, whether in DevTools manually or with some automatic tools that we use today. Next up, code coverage. So code coverage is really powerful. Today, you can use Chrome DevTools to see exactly which parts of your web page are used on the initial load, or anywhere actually. So this can help you avoid shipping unused code and slowing down your website. Puppeteer gives you programmatic access to all of the coverage things. So like tracing, you can start and stop CSS and JavaScript coverage around your interesting scenarios. So this was it for performance testing. And let's move to our very last topic about the features, called accessibility. So accessibility is very important today. And every other day is getting more and more important because we want to make our web content accessible to more and more people. Now, assistive technologies are hard to test for because you have to use switches or voiceovers or other things, and these have all very steep learning curve. Now, with Puppeteer, we hope to help you here. Puppeteer has a nice API called accessibility.snapshot, and this method returns a Chrome accessibility tree. Now, what is this? So this is this tree that all assistive technologists actually use to interpret the web content inside browser. So let's see what it looks like. So here, I can see that my website, Joel's website, has a name, an image, and a button. So this is a simplistic tree, which is very reasonable and easy to interpret. So with this tree, we can make sure that Joel's website has pay button, and pay button is actually visible through assistive technologies. So how do I do this? I open a page, and I fetch the button. Now I can get the accessibility tree starting in this button, and this root option is very important. And now I can make sure that it exists and has a proper name. Now, accessibility trees are fun to play with, but might be tiring to dig into. And we in DevTools work a lot with accessibility. So Joel built a tool called Accessibility Viewer. So Accessibility Viewer takes your web page, gets accessibility tree, and re-renders it as HTML. So here we can see Joel's website, and it been re-rendered in an accessibility viewer. So we see it looks reasonable and the same. There is an image, a selector, and a buy button. So with this tool, it is very easy to verify that the website is accessible. And here's the video. It is actually a small browser. You can navigate to different websites and interact with them. And this is google.com. It is actually looking reasonable, so it's very well accessible. Then we have another one, which is google.com.io. Okay. So this was it for accessibility. If you are interested in this stuff, let's go check out our GitHub. Okay, we are getting to the last topic of our talk. Let's talk about community. So Puppeteer is available on GitHub since 2017, and today, many big companies use it internally. Like companies like Google, but no surprise here, Netflix, or Facebook. Facebook uses Puppeteer internally to drive their performance analysis. So in fact, there are many other brands, but we cannot show them because it's crazy hard to get clearance to put a logo on the slide. But what's more important, that many folks, real folks, use Puppeteer in their day-to-day life. We have a Slack channel with more than 2,000 people in there. So if you have some question and you want asynchronous communication, please hop on our Slack channel and you'll find help there. Puppeteer community is not only embracing, but also contributing to Puppeteer. More than 100 people stepped up to help us maintain our API documentation. So with their help, Puppeteer documentation is always relevant and has all of these beautiful examples and code snippets. All our documentation is available on GitHub, so please come and help us too. Which is more important, community is actively contributing to the project. More than 20% of patches are core community contributions. And there is a lot of different tools around that use Puppeteer. So let me highlight a few of those. So first, a project called SizeLimit. SizeLimit uses Puppeteer to measure how much time it takes for a website to load and run all the JavaScript. So this helps web developers to stay aware of the size and their JavaScript cost and help them ship smaller and faster websites. Next example is called Penthouse. This is a similar tool, but for CSS. It extracts the critical CSS, only the CSS which is important for the initial website load. And with this, you can ship less CSS and make your websites load faster. Services, different services of the web now use Puppeteer as their API. Checkly lets you write checks in Puppeteer that validate important and crucial workflows against your production websites. There is a Chrome extension called Puppeteer Recorder. This extension records all your interactions with the web page and converts them into a Puppeteer script. And the last one here is Browserless. Browserless hosts some Chrome browsers in some offline magical place and lets you connect and drive them with Puppeteer. Well, there is even way more. Today, we have more than 1,700 packages dependently directed on NPM. Today, Puppeteer serves as a foundation for next-generation web tooling. And we are very happy to help web developers to make their websites faster and nicer. So this is the end of our talk. So thanks for sticking around. And quick summary. So Puppeteer is the official Chrome API to drive browser automation. We are excited about experimental Firefox support and with our collaboration with Mozilla. And modern web is testable. Testable is Puppeteer in both Chrome and Firefox. Here they are. Thank you. My name is Andrey. If you have any questions, please feel free to find me around.
Please, questions.
What language can I ask a question? first?
Any language,
Okay.
I guess. I understand
You
both.
have told that Puppeteer works with tablets and mobiles. Yep. So what about landscape and portrait modes? How it operates with them?
All of these are supported. You can have iPhone 8 or iPhone 8 landscape. These are available in devices section in Puppeteer.
So you can easily switch
Yes.
between them
Yes.
during the test.
Yes.
Okay. It was the first question. And last one, what about other browsers?
Oh, Firefox is there. We have a prototype of WebKit, but it's far from being any ready. If you care about other browsers, Edge is moving to Chromium, so Edgeium is supported. Opera works with Puppeteer. Electron works with Puppeteer.
Okay, and what about old versions of Chrome and Firefox, if we need?
So we ship monthly releases. So there is one Puppeteer version per browser. So if you get old version of Puppeteer, it will work with old Chromium.
I mean, you can switch with you can choose some old version. Old version of browser and choose it before testing.
Yes, by choosing the Puppeteer version, though. So one Puppeteer version works on with one browser version.
Okay, thank you.
Hello. My question is also about browsers. I'm interested, are those versions of Chrome and Firefox which are installed automatically with Puppeteer, are there any difference from real one, Chrome and Firefox?
Yes. So first, Chromium. So there is a Chromium and there is a Chrome. One is an open source project, another one branded with proprietary technologies. So these are different. For example, Chromium doesn't support all of the encodings of the videos. If you want to use those, you can use a matching Chrome version, but we cannot download it for you because of the license agreement. So you'll have to download it for yourself and then point Puppeteer to use it. You can do that.
Okay, thank you.
Hi, thanks for the good talk. This looks very impressive, all with dev tools and stuff. But what about Firefox? All this magic with mobile emulation and request injection, does it work in Firefox as well?
So it works, request interception works with continue and respond, I guess. Some of the functionality is currently missing in Neko. Neko is Firefox network layer. Firefox is actively collaborating with us to fix all of these things and actually to ship it out of experimental. So we hope it will work. Yes, we are making it work.
Hello, thank you for cool presentation and useful. You had a lot of examples when we have to wait for page or for some controls. But how to manage case if it will never appear?
So all of the wait for calls time out by default in 30 seconds. This is a lot, but you can actually change this and you can make them time out, and when they time out, they throw an exception. So yeah, if they don't appear at all, you will get an exception and your test will fail. Does it help? Okay. It throws timeout error, so you can handle it appropriately in your test if you wish so. It is of a type timeout error. It's a class. Mm-hmm.
Hi.
Hi.
Thank you. The question is it possible to make some screenshot compare with Puppeteer and any way to make a screenshot itself?
Yes, Puppeteer lets you do screenshots, and the screenshots that we generate actually are appropriate for the device you emulate. So if you emulate different DPI, we will have this DPI in your screenshot. It's a one-line command. It's just page.screenshot. It will output a screenshot for you. We don't do any comparison. This is up to you and your testing harness, but we can generate screenshots, yes.
Yeah, thank you.
У нас осталось время для одного вопроса. Я его там давно обещал.
Hi, thank you. Does your request library work with custom HTTP headers?
Yes, you can inject and you can observe all of the custom HTTP headers.
Thank you.